Thank you.
Welcome. Who's had one of the most interesting and, I guess, catchy titles we've seen in a long time. So he's going to be talking about how Python saved a rescue dog, right? So I thought it was a good one to get the day moving, a good story to share. So we'll do with Andreas. Thanks.
Excellent. I'm just setting up my timer. Just people are calling me exactly at that moment, of course. All right, so I'm delighted to be here this morning and give you a really feel-good story to start the day and get you going for the IoT track. So I'm going to talk, as the title says, how Python saved a rescue dog. And before I start with that, just a few words about myself. So I live and work in Melbourne and have been using Python for more than 10 years by now. And I've used Python for pretty much anything from scripts, automation, web services, motion controls, data analysis, and all these kind of things. So in my professional life, I'm working at the Australian Synchrotron, and you can see this here on the left. There's this round can-like building. And so what we are at the heart a particle accelerator. And you can see in the bottom picture what that looks like. And what this particle accelerator does is it generates really intense X-rays. And so we use those to do research, and it's very applied research. So we do research into heritage, like paintings, artwork, and these kind of things. We do drug development. We're really strong in cancer research, and a lot of other things. We are a government research facility, so your tax dollars are at work here every day, and they pay my salary, so I'm very grateful for that. And so what I do every day is I develop scientific software, and most of the time it's Python. It interfaces a lot with C, C++, but most of the time it's actually Python. But this talk is not about me. This talk is about our dog. That's Willow. She's an English Bull Terrier. And what I would like to tell you is her story. So it all started in September last year. My partner had accrued a lot of leave, and she took 4 weeks off. And we were like, what should we do with the time? We should make a difference. And so we wanted to foster a dog for quite a while. And so we reached out and tried to foster a dog. And fostering a dog, what that means is you look after a dog for a limited time, and in the time you prepare the dog for adoption. So you only have the dog for a while, and then you give it away. We reached out to the Victorian Bull Terrier Rescue, which is a not-for-profit organization and charity in Victoria, and they look after all kinds of Bull Terrier rescues that emerge in Victoria. The way you get a foster dog is you write an application, they come to your house, they check whether your house is safe, they do an interview with you to see whether you're suited to have a rescue dog, check your character, whether you're okay. And we've done all these things, and we were successful. And we got Willow assigned. And you see a picture of Willow down on the bottom left, and that's what she was, I think, 2 days after we got her. She was well underweight. She was really badly treated by her previous owner. We were told we were her last hope, so if we didn't get her back up, she would probably be put down. And what she has developed due to the bad treatment is a compulsive spinning, and so she was chasing her tail all the time. And this is why she's wearing the cone of shame, because she can't see her tail, and so she kind of stopped spinning, but sometimes she would get into it, and it was pretty bad in the first weeks. So what we did is we put a lot of intense work together with a vet and a dog behavior specialist into it, how to stop that, and we ended up developing a quite rigid medication schedule where she was given anti-anxiety medication. So she got one in the morning, one around 2 p.m. in the afternoon, and one in the evening. And some of the drugs had to be delivered really on time. So we went with that for 4 weeks, every day, dealing with her, training with her, giving her the medication. And it really paid off. So after those weeks, we saw her improve a lot. So you can see in the top right corner that at some times she didn't need the cone of shame any longer because we just taped her tail to her leg so she couldn't see it. That worked surprisingly well. So in those weeks, she really improved a lot. But then the 4 weeks ended. And my partner had to go back to work, and we both had to work full-time again. So could we keep fostering? Because she really felt comfortable in our house. She felt safe. And what could we do about it? So we had to face two problems. The first one is, can she be by herself during the day if you were not home, obviously? And the second one is, this 2 p.m. medication in the afternoon, can we give it to her somehow from work? So to attack the first one, what we did is we increased the time she was alone. And so we bought a webcam, had an app on the phone, and so we would watch what she were doing while we were out. And surprisingly, it worked really well. She kind of liked being by herself. To be honest, she slept most of the time, so that helped with that. So once we've got that sorted, we looked at the second question. And how would we be able to feed her remotely? So we looked at the market. There's a market for dog feeders. And basically, all of them are ground-level based, so these little dispensers that you put on the ground. The problem is she's a highly food-motivated dog. She would have ruined this in half a day. So no way to get this. And everything else you find in the market are silly gadgets of cameras that follow the dog around, things that don't really make a difference in this case. So it was well and truly time to do some proper DIY. So what we did, we went to the local hardware store. We went to the local cheap electronics store. Everyone in Australia can guess what these brands are. And so we went out and we bought a few things. So what you can see in the picture is we bought a pretty much standard servo. We attached the cap of a fence post to it. And so what the servo would do, it would just rotate 180 degrees and tip the medication to the ground. The medication, I should say, what we developed over the time is a piece of salami with cream cheese and the drugs inside. So it was basically a little burrito she gets every day, and that works really well in this dispenser. This dispenser is made on purpose really simple, so nothing can go wrong, because it's so important to have that. We mounted it to the top of our bookshelf, so she can't reach it. And I happen to have lying around an Onion Omega-2 from a recent Kickstarter. I backed because I was bored and so I back things. And what the Onion Omega-2 is a little IoT device. You can see a picture down here. Decently clocked, quite a lot of RAM, 32 megs onboard flash storage, and it runs a full, really stripped down Linux on the 32 megs, and it's called a Linux Embedded Development Environment. I think it's a fork of the OpenWRT Python Linux, and it runs Python. So as soon as I figured out I can run Python, I was like, I can solve the problem. We can get this done. And the way I approached it from a software point of view after the hardware wall was sorted is the following. So first of all, I got a virtual machine in the cloud. Just a commercial cloud provider, put a virtual machine on it. I wrote a web application with Flask. That's my preferred micro framework for writing web applications in Python. And I put a Redis database behind it. So if you haven't heard of Redis, Redis is a key value database. It's mainly in memory. It's really fast. And it supports a lot of different types of values, not only like strings, but also lists and sets and other things. So once I had this, I wrote a really simple web application. It's literally just a web page with buttons. That's all you need at this point. And if you were to press a button, say you press the feed button up here, it is a bit of JavaScript that sends a request via the internet to my virtual machine. And it would then add to the database into a list an action. It would say you press the feed button. OK, you've got an action feed in your list. And the same thing is if you press the home button, it would add an action home. So the idea with feed and home is feed would tilt it 180 degrees to tip it off, and home would send it back to its home position. So OK, so I had a list of actions in my virtual machine in the cloud. So the other thing I had was the Onion Omega-2 IoT. And I had a Python script running. It was literally just an infinite loop script that would, at the moment, every second, just poll via the internet to the API of the virtual machine, to the Flask service, is there an action for me? If there is an action in the list, it would pop off that action, would send it back and say, yes, there's an action feed. And then the IoT would get this action and say, good, now I know I have to feed. And it would call the servo via a little pulse width modulation head, tilt the servo, tilt the cap with the feeder. And that works really well because it has one big advantage. The polling scheme, the polling architecture, means it's really reliable. If the virtual machine goes down, it would just poll into nothing would get back an error code that could record this, and that's it. Or if for another reason the IoT device goes down, nothing would really badly happen. There's no synchronization needed between an IoT and the virtual machine, so it's a really simple scheme. Also, it kind by nature comes with health checks, so any kind of heartbeat is really simple because every request, every poll would be a heartbeat. So I would always know, is the IoT still there or not? Has it died on the other end? The disadvantage is, because it does polling and I didn't want to be super crazy with it, I poll every second, there's a lag between the time you press a button and something happening on the other side, which for feeding is fine, but if you, for example, were to go further in the future with, say, measuring temperatures, real-time values, that's kind of not optimal. And it's not really scalable either, because there's a very strong dependency between your IoT and that virtual machine on the other end. But it worked. And so the first development system that we built was this medication feeder. And we also attached an audio speaker system that's just a really cheap USB audio adapter and just use the standard Linux ELSA libraries to play a wave file. So we opted for a cuckoo clock. And the idea was that every time, before we actually feed the dog, we would play this cuckoo clock. And then she would know, OK, food is coming. I mean, like, kind of you give the dog another type of OCD at this point because she like gets used to that. But all right, it's better than spinning. We even went a step further for the real production system that we then went with for a long time, is we decided, hang on, we need treats. Sometimes during the day you feel like, oh, I miss my dog, I want to give her a treat. So we built this little treat feeder, which is, again, just hardware store aluminum profiles screwed together to build a little kind of chute. So you put your treats into the chute, and at the end is a servo-driven shovel that would just tip them out. And that worked really well for those, if you have a dog, these really hard training treats, they would go down quite well. If you have anything soft, that kind of doesn't work. What it also showed is that just having IoT is only part of the puzzle, because we had to train the dog to actually react to these things. So it was like this thing where we had to train the dog and get the IoT working. Once you had both, it worked really well. So we were running with this setup for a couple of months, and how did it go? Actually, surprisingly well. So we every single day during the work week, we could administer the dogs. We could be at work, so that worked really well. Until summer came. And we had power outages in our street more than we usually have. Interesting enough, in some cases, the internet was still up because it only affected the street, not the interchange a few streets down. So first thing I did is just added an uninterruptible power supply to the whole system so that my whole network infrastructure was still up if the power went down, including the feeder. So at this point, we were like, yes, that's all working. And over that time, over these months, we did it every single day, her behavior got better and better and better. But still, nobody had showed up to adopt her. Nobody was interested. And it was January at this point. So we adopted her. So mid-January, she was ours. And so she became a foster fail. And a foster fail is someone who's fostering a dog, then falls in love with the dog, and then you adopt it. So you totally failed at your job at fostering that dog. At this point, because we now knew we had her for pretty much ever, now it's time to get serious. And with serious, I mean, you know, at work you have to be efficient, you have to be sensible. That's at home, I can do whatever I like. So it was time to add more. It was time to add scalability to it. So what I wanted to do, turn a lamp on and off, so it slowly got into winter, and I didn't want her to sleep during the whole evening, so I wanted to turn on a lamp when sunset was approaching. Or I wanted to check my UPS update. Is the power out again? Or measure the temperature. Is the poor dog cold? Should I do something? I wish I could turn on the temperature automatically in my house as well. That would be ideal, but I can't. So the way I approached that is I decided to go and split it into infrastructure and services. And because I'm a big fan of microservices, so what you'll see is a very weird hybrid of IoT with microservice architecture. So you have, on one hand, the device. So that's my infrastructure. And so I went from an Onion to a Raspberry Pi and Raspberry Pi Zero. Not sure whether that still qualifies as IoT, because this is now a pretty powerful PC running Linux. So sorry for the track conveners. But each device is then connected to a very specific output board and to some I/O board to sensors. And so for each physical function, for one that measures temperature, for one that steers servos, for one that turns a lamp on and off, I had a separate Raspberry Pi. Why not? And so my idea was to have just minimal configuration on the device, minimal configuration I needed to get it running, and I just run a Docker daemon on it. That's all it is. And then the service side, I opted for web services, which are, again, written in Flask, my favorite framework, and they just expose a RESTful API. So I can just call things. Now, all the services I will put on all these devices have to find each other. So I needed kind of a service discovery thing. And I was looking at it, and I didn't want to put Kubernetes on it because that seemed too crazy. So I opted for Consul. That's an open source tool from HashiCorp. Which is really nice because your service discovery acts like a DNS. So if you ever did DNS resolving, that works the same way. So that is really nice. Every service is packaged up in a Docker container. I already said I'm running Docker on my devices. And everything is then deployed with Docker Compose. If you haven't seen Docker Compose yet, it's a way to have all the different Docker images that you want to deploy in one file, so, which means each device, the infrastructure has one Docker Compose that says all these services run on this device. And I host everything in my GitHub, and I put those private because otherwise people find security holes and I'm in trouble. So with that in place, the infrastructure changed a little bit. So I still have the same website. I haven't changed this. I still have the same virtual machine in the cloud. I haven't changed this yet. But now, instead of having this single IoT device, I have a Raspberry Pi 3, just had this one lying around, and that runs a whole range of services. So the top one is a simple gateway service, and that's meant to talk to the virtual machine and get the requests from the web application. And in order to run the whole show, I needed a Docker registry where all my images live, and so that Raspberry Pi also runs my Docker registry. For my service discovery, the Consul server runs on the Raspberry Pi 3 as well. And then there's a service called Registrator, which is pretty neat because what it does is every time you start a Docker image or a Docker container, it would register it automatically to Consul. So I didn't have to configure anything. It's a zero configuration system, which makes it really neat. So this is my gateway in the front. And then, as I already said, each device is its own Raspberry Pi Zero. And I really like these little things because they're small. They don't draw too much power. You can get these little tiny heads on top, so it makes a really small package. And so, for example, I have one that would talk to the servos for the medication. And it would run two services for the medication. And here, for example, the scalability comes in quite neatly because the medication 01 and medication 02 is the exact same Docker image. I just started twice. In the configuration, I just say, number 1, you go to pin number 1 to talk to the servo. Number 2, you go to pin number 2 to talk to servo 2. So it makes it really scalable. So if I want to add additional servers, I just have to start more of those things. It runs a little bit of infrastructure. So every time you do microservices, your infrastructure services explode. And so, for example, it runs a Consul agent, so it can then do the service discovery. And again, the registrator, so it all automatically registers to Consul. A second example is the lamp that I said to turn on and off. That one talks to a solid-state relay. So that's a simple solid-state relay. And you have the lamp go in on one side, and you just supply between 3 and, I can't remember, 23 volts on the other end. And then it just opens and closes the relay, and you can turn a lamp on and off. That works really well with Raspberry Pis as well. And so, again, a service that just does on and off on a Raspberry Pi that has an analog out. And a Consul agent, a registrator again, and off you go. So the way it works at the moment, again, you click on a button. It adds an item to the list of actions. Instead of having the IoT device to poll, I have the gateway service doing this. So the gateway service would ask, is there a new action to be done? Yes, there is. And then instead of actually doing the work like what we had previously, it would just do REST calls to the devices that know how to do it. So for example, if there is a feeding to be done, it would send it to medication 1. If I want to have a second one, and so what we added is a second one for the 9 p.m. drug, so we could go out in the evening. So you see we stepped the game up step by step over the months. Or, for example, turn the lamp on and off, would do a REST call to the lamp. So that's nice, but what's the future? I would like to use WebSockets instead of polling. That seems a bit more appropriate. It adds more complexity, but I would like to have like real-time feedback from sensors, temperatures, all kinds of things, check that doors have been closed. I mean, like it's endless. Because for once with this, I had IoT, which was not a solution that was looking for a problem. I actually had a problem and I couldn't solve it. So very often I found myself with the problem. I have a Raspberry Pi, and I'm like, what do I do? Everybody has done media centers. I just don't want to do it again. So it will explode over the time now. I want to do event-driven. Everything at the moment is RESTful, so it's request response. But I would like to have events. MQTT is what I'm probably going to use. Things such as a temperature measurement just broadcasts to everything, and then people can pick it up. Or you have a brightness sensor. It says, it's getting dark. Hey. And then the lamp says, oh, that's a good idea. I should turn on. And the other thing is my interface is really simple, just plain HTML, vanilla JavaScript. I want to go with React, and I want to do React for a while. My whole team is doing React. I don't do it yet, so that's a great reason to do it. And here is a list of all the tools I've been using. As I said, I'm a big fan of Flask, the Redis database, console for service discovery, Docker everywhere, which kind of destroys a little bit the IoT concept, but hey. And the registrator and my Onion and the Victorian Bull Terrier Rescue, who were really helpful. And yeah, I'm well ahead of time, so I'm happy to take questions at this point. Thank you.
So does anyone have, we do already, okay.
Thank you, great talk. What was the name of your dog?
Willow. Yeah, so she had another name when we got her, but because people thought that might be, because that name was the original name with the original owner, so people thought like, oh, there's maybe a correspondence like with her OCD, so she got renamed, and yeah.
Why didn't you go with Docker Swarm for the service discovery?
Yeah, I was thinking that. You could have done Docker Swarm, and there are plenty others. I don't know. I wanted to use console for a while. I really like the idea of it being just a DNS server, that I can just use standard DNS tools to find my services, and that was something I really like. Also, I think at this point there was a big debate going on, Docker Swarm versus Ranger versus Kubernetes versus all these other orchestration tools, and I didn't want to be part of that. Not that I put Docker Swarm on and then they decide to remove it because Docker changes all the time.
Great. we're going to have to cut it off there. I'm sorry, Andreas. I'm sure there's a lot of people with other questions, but we're running really short on time. First of all, I've got to grab one of the amazing mugs.
Thank you.
Very much for your talk.
Thank you.
Oh, thanks again.